Hey, welcome back to video number 5 in the notes for inequality and interval notation. And in this example, we are describing intervals. So in the graphic organizer on this page, I've put examples of some bounded intervals, some half-bounded intervals, and an unbounded interval. And I'd like you to pause the video and just look at those examples carefully, write down a definition for each of those different types of intervals. And then when you're ready, go ahead and turn the video back on and we'll see what they mean. Okay, so a bounded interval, when you look at these examples, you'll notice that there's an endpoint on either side, right? This is the interval -2 to 17 non-inclusive, 1 to 7 inclusive. Here in inequality notation, the x is between 2 and 5 non-inclusive. So in all of these, there are endpoints. Okay, and a bounded interval then is an interval between two real numbers, right? Between those endpoints on the number line, there would be shading. If we were doing an inequality notation graph, it doesn't matter if they're brackets or parentheses. In this situation, to be bounded just means that we've got real number endpoints. Okay, a half-bounded interval can be an upper bound or as in this example, the 8, or it could be a lower bound, as in this example, the -4 is a lower bound. Those bounds can be inclusive or non-inclusive, but what's important in a half-bounded interval is that one end is approaching infinity. So here, this is going toward -infinity up to and including 8. Here we have -4 up to and -4 all the way through to positive infinity. This inequality notation, x is less than 5. And then in the middle here, we have what is a union of half-bounded intervals. So -infinity to 1 inclusive, that's a half-bounded interval. And then union, remember, joins it up to this second interval, 4 to infinity non-inclusive. So half-bounded interval contains at least one infinity, and it has one endpoint. Okay, then an unbounded interval that's completely unbounded is the interval of all real numbers, -infinity to infinity. And there are no endpoints in that situation. And in the notation for Algebra 2, you probably have seen this before. It's a capital R with 2 lines in front of it. That's the notation for all real numbers. So you can write your interval this way, -infinity to infinity. You can use that all real numbers symbol, or if you were doing an inequality, you could write -infinity is less than x is less than positive infinity. Right? Those 3 are all saying the same thing, the interval of all real numbers. Okay, so for your notes then, there's a snippet here directly from the textbook. An interval is said to be left-bounded or right-bounded if there is some real number that is respectively smaller or larger than all of its elements. These are the left bound and the right bound in this interval. Now the next sentence says that an interval is said to be bounded if it is both left and right bounded. So this example we were looking at here, -2 to 17, it's left bounded, it's right bounded, which is the reason why we call this a bounded interval, right? Okay, so the next part of that statement says it is said to be unbounded otherwise. And you'll notice in the unbounded column here, we only had one example, -infinity to infinity, as an unbounded interval. It's not strictly the case. These half-bounded intervals are unbounded on one side, right? So we have -infinity to 8. It's unbounded at -infinity. It's right bound is 8. So unbounded on the left and bounded on the right. And that's where this half-bounded idea comes from, which we can see here in the next statement. Intervals that are bounded at only one end, so only one end, right? Those are said to be half-bounded. So half-bounded here in the middle, right? They are bounded at only one end and unbounded at the other end. That's why those are called half-bounded. So this unbounded at the end, this is the interval of all real numbers is referring to an interval that is unbounded on both sides. Okay, if that helps clarify what that means. Then as we continue on, the empty set is no numbers whatsoever. So no solution. When you're doing an equation, you get an answer that is no solution. That's an empty set. That's a bounded interval. And then the set of all real numbers is the only interval that is unbounded at both ends. And that was what we had just said a moment ago, right? Set of all reals is the only interval that is unbounded at both ends. And that's what this is referring to, right? When we say it's fully unbounded, that's our set of all real numbers. Okay, so now I'd like you to pause the video again and give this example A, this try it now problem a go. You're going to read this verbal statement and then translate it into inequality notation, interval notation, then sketch the interval notation and decide is it bounded, half-bounded, or fully unbounded. Okay, so let's go over this solution. X is at least 3 and no more than 7. So in inequality notation, that would be the 3 less than or equal to x, less than or equal to 7. Interval notation, because at least is inclusive and no more than 7 includes the 7, we're going to have brackets on both ends of that interval. And the sketch then is going to also have brackets with the brackets facing in, right? Because the shading is implied to be between them. And then that is a bounded interval because it's bounded on the left and the right. It's a fully bounded interval. Okay, so then you're going to pause the video again and go ahead and try example B. And then when you're ready to resume, we'll go over the answers. So x is less than -1, or x is greater than or equal to 2. So in inequality notation, since it's less than -1, there's not going to be an equals there. That's non-inclusive. The or is going to be written as the word or because it's two separate intervals. X is greater than or equal to +2 would be a second interval with an equals. So in equality notation, we have x strictly less than -1 or x is greater than or equal to 2. Okay, in interval notation, remember we don't write the word or, we use a union symbol to join those two intervals together. So we're going to have the union of two half-bounded intervals, -∞ to -1 non-inclusive, union 2 inclusive up to infinity. Okay, here is the sketch. The parentheses should be facing -∞ at -1. The bracket should be facing +∞ at 2. And that is union of half-bounded intervals. So we listed half-bounded there in the description. And that brings us to our secret question for this lesson. If you remember in the WSQ description that we looked at together in the introductory lesson, you want to always write down the secret question that you see in the video. Sometimes it's at the beginning, sometimes it's the end, you just don't know, but jot down that secret question and then solve it and make sure that you upload your solution when you upload your notes to Schoology. So this problem, I'm not going to reveal the answers in this particular video. I will release them once everybody's turned theirs in and I have a chance to see how everybody did. Okay, so jot down the secret question here in your notes and give it a try. You're going to fill in all of the missing information on this this table here and do your best, and we'll see how it goes. All right, thanks.